Overview on LT4356 Surge Stopper by Linear Technology Corporation. Welcome to the training module on LT4356. The LT4356 is an overvoltage regulator and surge stopper. Our training outline consists of features and applications, block diagrams and performance curve, application information, MOSFET selection, and reverse input protection. The LT4356 surge stopper protects loads from high voltage transients. It regulates the output during an overvoltage event such as a load dump in automobiles by controlling the gate of an external N-channel MOSFET. The output is limited to a safe value, thereby allowing the loads to continue functioning. The LT4356 is an overvoltage protection regulator that drives an external N-channel MOSFET as the pass transistor. It operates from a wide supply voltage range of 4 volts to 80 volts. It can also be pulled below ground potential by up to 60 volts without damage. The low power supply requirement of 4 volts allows it to operate during cold cranking conditions in automotive applications. Some of the applications for the LT4356 include automotive and avionics surge protection, hot swap, and high side switch for battery-powered systems. Here's a block diagram of the LT4356. This block diagram includes an internal amplifier, auxiliary amplifier, control logic, internal timer, PNP transistor, and back-to-back FETs. The LT4356 monitors the voltage drop between the VCC and SNS pins to protect against overcurrent faults. An internal amplifier limits the current sense voltage to 50 millivolts. In either fault condition, a timer is started inversely proportional to MOSFET stress. If the timer expires, the FLT pin pulls low to warn of an impending power down. If the condition persists, the MOSFET is turned off. After a cool-down period, the gate pin pulls up, turning on the MOSFET again. The spare amplifier may be used as voltage detection comparator or as a linear regulator controller driving an external PNP pass transistor. Back-to-back FETs can be used in lieu of Schottky diodes for reverse input protection, reducing voltage drop and power loss. A shutdown pin reduces the quiescent current to less than 7 microamps during shutdown for the LT4356-1 and 60 microamps for the LT4356-2 while keeping the reference and auxiliary amplifier functioning. The fault timer allows the loads to continue functioning during short transient events while protecting the MOSFET from being damaged by a long period of supply overvoltage, such as a load dump in automobiles. The LT4356 senses an overcurrent condition by monitoring the voltage across an optional sense resistor placed between the VCC and SNS pins. A spare amplifier is provided with the negative input connected to an internal 1.25 volt reference. The output pull-down device is capable of syncing up to 2 milliamps of current, allowing it to drive an LED or optocoupler. A shutdown pin turns off the pass transistor and reduces the supply current to less than 7 microamps for the LT4356-1. This slide illustrates the performance curve for the LT4356 device, comparing input voltage and output voltage. This circuit was designed for overvoltage protection. It regulates output at 27 volts during surge transition. This slide offers application information on overvoltage fault and overcurrent fault. When the voltage regulation loop is engaged for longer than the timeout period set by the timer capacitor connected from the TMR pin to ground, an overvoltage fault is detected. An overcurrent fault occurs when the current limit circuitry has been engaged for longer than the timeout delay set by the timer capacitor. This slide offers information of the circuits that can be implemented using its internal resources. The amplifier can be connected as a level detect comparator with external hysteresis. The amplifier can also be configured as a low dropout linear regulator controller with an external PNP transistor. Overvoltage fault timer current. The LT4356 includes an adjustable fault timer pin. Connecting a capacitor from the TMR pin to ground sets the delay timer period before the MOSFET is turned off. Once a fault condition, either overvoltage or overcurrent, is detected, a current source charges up the TMR pin. The current level varies depending on the voltage drop across the drain and source terminals of the power MOSFET, which is typically from the VCC pin to the out pin. During an overcurrent fault, it starts at 4 microamps with 0.5 volts or less of VDS but increases to 260 microamps with 80 volts across the MOSFET. In the case of an overvoltage fault, the timer current then switches to a fixed 5 microamps. The LT4356 drives an N-channel MOSFET to conduct a load current. The SOA of the MOSFET must encompass all fault conditions. In normal operations, the pass transistor is fully on, dissipating very little power. During overvoltage or overcurrent faults, the gate pin is served to regulate either the output voltage or the current through the MOSFET. The SOA curves of the MOSFET must be considered carefully along with the selection of the fault timer capacitor. During an overvoltage event, the LT4356 drives a series pass MOSFET to regulate the output voltage at an acceptable level. The load circuitry may continue operating throughout this interval, but only at the expense of dissipation in the MOSFET pass device. MOSFET dissipation, or stress, is a function of the input voltage waveform, regulation voltage, and load current. The MOSFET must be sized to survive this stress. This diagram is used for overvoltage regulator with N-channel MOSFET reverse input protection. The LT4356 is designed to withstand reverse voltage without damage to itself or the load. It can be approached with a P-channel MOSFET in place of Q2. Typical application circuits include light input that ranges from 5 volts to 28 volts hot swap with undervoltage lockout, overvoltage regulator with undervoltage lockout, and 2.5 amp 48 volt hot swap with overvoltage output regulation at 72 volts and UV shutdown at 35 volts.